Okay, so you guys have y equals 3/2 the cosine of pi over 2x plus pi minus 3. So we have up here the general form, and we need to write that equation in general form before you can identify a, b, h, and k. So what we need to do is factor out b from this equation. And so if pi over 2 is b, then this term right here, the pi, is the result of multiplying pi over 2 by h. That is, if inside our cosine function we have b times x minus h, what you have written here is basically bx minus bh. So in order to get back, we're going to divide both terms by b. Right? So basically, we're going to take pi and divide it by pi over 2. So take pi and divide it by pi over 2. But in order to do that, we need to multiply by the reciprocal. So pi times 2 over pi, which of course pi is over 1, and the pi's divide out. So that means h is 2, right? So to get h, we're going to divide this by b, right? And that gives us h, which is the 2 we have here, right? Because it would have been x plus 2. So once we do that, now we have pi over 2 times x plus 2. But general form again, general form uses a negative, right? X minus h. So we have to rewrite this as x minus negative 2, which would be x plus 2. Okay? So from here we can identify a, b, h, and k. So we can say if a is amplitude, right? If a equals 3/2, that means amplitude is 3/2. If b is pi over 2, then that means that the period is 2 pi over pi over 2, right? Because the period is 2 pi over b. So that means that the period is going to be 2 pi over the absolute value of b. b is already positive though. So pi over 2. So when you divide, you multiply by its reciprocal. So this is really 2 pi times 2 over pi. 2 pi times 2 over pi, which again 2 pi is over 1. The pi's divide out, and we get a period of 4, right? Now h is our phase shift, and so with h being our phase shift, we are going to say h is negative 2. That means for the phase shift, we are moving negative 2, which means to the left 2. Good. So to the left 2, right? Okay, so what does that mean for our graph? If you look back at what you did with the Ferris wheel problem. Remember with the Ferris wheel problem, right? We said our phase shift here was 2.5 minutes, right? That means that our sine function started at 2.5 minutes, right? And so if we were to make an XY table for this graph, we would probably start our x's at 2.5 to get a true sine function, if we wanted just the sine function. Not in real life where it's starting, but where the actual sine function itself is starting. We would start at 2.5, right? Well, isn't that h? Didn't we just say that was h? So that means when we identify h as negative 2, we're going to start counting at x equals -2, right? And what do we count by? When we look at the intervals for our sine function graph, if you remember for the Ferris wheel problem, our period was 10 minutes, right? Period is 10 minutes. But we didn't count by tens. We counted by 2.5, which was the period divided into 4 equal intervals, right? Because if you think of your unit circle, important points, midline max, midline min, those happen at 1/4 of the period, right? If a period is 2 pi, we divide that by 4. Pi over 2, pi, 3 pi over 2, 2 pi, right? Add your starting point. So for this graph, if we want to think about where we would go with it, if the period is 4, what are we going to count by? 4 split into 4 pieces, which would be 1, right? Okay, then we know k equals -3, right? Which means we have a midline at y equals -3, right? Yes? Okay, so let's make a graph of this, which I know you guys haven't done yet. Period 2, you haven't done it yet either, but period 5 hasn't done it. So in your notes, if you open your notes, if you're looking at what we did yesterday, I want to add to this example. So let's say we wanted to graph this, not just identify all the important parts. So if we wanted to make an XY table for this, right, where would we start counting? We're going to start counting at h, right? So we're going to start counting at -2. And we're going to count by intervals of 1, because that's 1/4 of the period. And all of our big points are going to happen at every 1/4 of the period, right? So the XY table that I'm going to create is going to look something like this. It's a little different than the XY tables you're used to. You're used to vertical XY tables. We're going to make a horizontal one, but leave some space because we're going to have 3 lines. So our x values are going to start counting at h, right? Because we're going to start at the phase shift. So we're going to start at -2, and we're going to count up by 1. So -2, -1, 0, 1, 2, right? Now, if we think of a traditional cosine function, so if you look back in your notes from the very beginning with your cosine function, right? If we were to make an XY table for your cosine function, right? Our x's are going to happen at 1/4 2 pi intervals, right? That is 2 pi divided by 4. So we're going to start at 0, and we're going to count 2 pi divided by 4 would be half pi over 2, half pi, right? Which we already know. So we would count at pi over 2, pi, 3 pi over 2, and 2 pi, right? Yes? And so our cosine function is going to go 1, 0, -1, 0, 1, right? So at 0, our cosine function is 1. At pi over 2, our cosine function is 0. At pi, our cosine function is -1. At 3 pi over 2, our cosine function is 0. And at 2 pi, it goes back up to 1. You could do the same thing for sine. If we look at the sine function, we're still counting by 1/4 of 2 pi, right? We're still counting by pi over 2. So we go 0, pi over 2, pi, 3 pi over 2, 2 pi, right? But the sine function doesn't start at 1. Sine function starts at 0, goes up to 1, back to 0, -1, 0, right? So 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, 2 pi, 0. So if we think of these as the parent values for sine and cosine, and we look at this given equation, right? Our cosine parent, right, after it's been shifted by the x values, right, the parent cosine should start up at 1, right? And go down to the midline, go to -1, then back to the midline, then up to 1, right? So really the cosine function should be 1, 0, -1, 0, 1. But that's not what's going to happen. Because what do we have? Amplitude and midline, right? That means we're stretching our graph, right? And then we're moving it up or down. And so if we look, the amplitude is multiplying, right? And then we subtract 3. So we have to follow order of operations, PEMDAS, right? We have to follow the order of operations. So that means from our parent cosine function, which we've shifted to represent the phase shift and the period change, right? We have to take what would have been our y values and adjust them by the amplitude and then by the midline. So basically, we're going to take our parent cosine function, multiply each y value by a, or 3/2 in this case, and then add k, or in this case, subtract -3. So by what we just said, to find our y values of 3/2 cosine of whatever's there, which I guess you could leave as a question mark because it's not technically x yet, right? And then we're going to subtract 3. So if I took 1, which is what I would end up with if I put in -2 for x, right? If I put in -2 here, I'll get 1 out, right? The cosine of 0 is 1. I'll multiply it by 3/2, so that's 3/2, and then subtract 3. And I get 3/2 minus 3 is -1.5 or -3/2. Always check your first point. Check first point in the original equation just to make sure that it works. Yeah.
Should we always put it in fractions, or
it doesn't really matter? I would leave it in fractions just in case you have a repeating fraction. You want an exact answer. You don't want to deal with run-on decimals. 0.5s, 0.25s, that's not a big deal. But you shouldn't be writing 1.333. You should write 4/3. Yeah.
I'm just a little confused on how the h comes into play. Or not comes into play, but how do you get that when you change the equation up top into general form?
Okay, so we found h, right, by factoring out pi over 2 from pi.
Okay.
Right? So we divided pi by pi over 2. When you divide by a fraction, you have to multiply by its reciprocal. Pi times 2 over pi is 2. Divides out, yeah. So h is almost 2.
Okay.
Because this becomes 2, right?
Yes.
Right? Almost h. I shouldn't have written equals h. This, we're finding this part, right? But this is plus, so we have to change it to subtraction. Right? So now it's in general form. And then once you get h, you know where your function starts. Right? Because h is your phase shift. So h tells you where the period starts. Your first full period starts. Right? And then the period, or excuse me, the function takes a period to finish, right? So if we split that into the 4 parts, you get your intervals, where you get your maximums, your minimums, and your midlines. just like going around the circle. Okay? So if we shifted by -2, then we're going to count by 1 because our period is 4. So if we start at -2, the next important point is going to be at -1, then 0, then 1, then 2. And in a traditional cosine function, we should be at our maximum, go to the midline, go down to the minimum, go back to the midline, go up to the maximum, right? But here, our maximum value has been amplified by 3/2 and then translated down 3 units. So 1 times 3/2 is 3/2. 3/2 minus 3 is -3/2, or -1.5. So to check that that first point works, let's put it back in the equation and just make sure we didn't do any wrong math. So we have 3/2 the cosine of pi/2 times, we think the starting x value should be -2, right? Plus pi, all minus 3, right? Well, if I put that in, -2 times pi/2 is you get -2 pi over 2, which is -pi, plus pi is 0. And that's what we wanted to do, right? We wanted to get back to finding the cosine of 0. We wanted to get back to our starting point of cosine. Well, the cosine of 0 is 1, right? Times 3/2 is 3/2 minus 3 is -3/2, which is what we wanted. Right?
Will it always come out to 0?
Yes. This argument, the b times x minus h, for your starting point should come back to 0. Because that's the whole point. We're shifting the graph to the left -2, right? So when we put in our calculations, it should shift it back to our starting point, even though our starting point isn't at 0 anymore. Right? Okay, so from here you have 2 options. You can continue to multiply by a and add k, right? Which would result in 0 times 3/2 is 0, minus 3 is -3. -1 times 3/2 is -3/2, minus 3, -4.5, or -9/2, because -3/2 minus 3, -3 is like -6/2, right? -3/2 minus 6/2 is -9/2. 0 times 3/2 is 0, minus 3, which makes sense because if you're at the zeros, you should be at the midlines, right? Which the midline should be -3. 1 times 3/2 is 3/2, minus 3 is -3/2, which makes sense because that should be our maximum values, right? The other way to do that is to start at your starting point. You know this is cosine, so this should be a maximum value. To get to the midline, you should go down by the amplitude, right? So if you subtract 3/2, you should get to 3. Well, -3/2 times minus 3/2 is -6/2, which is -3. Then cosine function goes down to its minimum, which is an additional 3/2 below that. Right? So -6/2 minus 3/2 is -9/2. Then the cosine function goes back up to the midline. Add 3/2 back, that's 3. And then it goes back to its maximum. Add another 3/2. Now we're back at -3/2. So that works out for us also. Okay? So both ways to do that. To graph, we're going to graph our x, y values, right? So we're going to graph -2, -3/2, -1, -3, 0, -9/2, 1, -3, and 2, -3/2, right? So our x values should go between -2 and 2. Our y values, we want to make sure we're between -1.5 and -4.5, right? Yes? Okay. So if I count by halves here, this would be my x-axis. And then I want to be -2 out, right? So if I count by halves. So -1, 0. So I'll have to count by halves. So 1, 0. So here. So this is my y, this is my x. -1, -2, 0 obviously, 1, 2, right? And then I said I was going to count by halves. So here's -1, -2, -3, -4. I should have extended. -5, right? Yeah? Okay. So my midline happens where? -3, right? So graph your midline. That'll help you see your cosine function. So label y equals -3, right? Yes? Then graph your points. So -2, -3 halves. -2, -3 halves. -1, -3, -1, -3. 0, 9 halves. 1, -3. 2, -3 halves. And you could continue that. You know 3 is going to go back to -3, right? And continue forever. So when you draw your cosine function, you want to get a nice curve. And there we go. All right, any questions?
Can you go over how you found the point again?
Okay, so you can, from the start, are you okay with getting the starting point?
No.
Okay, so we know that our original cosine function starts at the maximum value of 1, right? This function has been stretched by a factor of 3 halves, right? So that would stretch 1 up to 3 halves. 1 times 3 halves, right?
Yeah.
Okay, and then it shifts it down by -3. So 1.5 minus 3 is -1.5, which is -3 halves. And so from -3 halves, we go down 3 halves more to -3, down 3 halves more to 4.5, up 3 halves, because our sine function always goes maximum, midline, minimum, midline, maximum. Okay. All right, any other questions?
When you did your period,
Mm-hmm.
you did how 360 degrees is in radians, like 2 pi over the.
When you you mean to find the period or to figure out what you're counting by?
To figure out what you're counting by.
If you think of a unit circle, right? Your unit circle, the important parts are happening at every quadrant change, right? There are 4 quadrants in a circle. So each of your sine and cosine functions are going to have important points at a quarter of the period, right? So 2 pi divided by 4 is pi over 2. So that's why if you start at 0 and you have 4 intervals of pi over 2, you get your full period. So that's why you have 5 points, because you have your starting point and then the end of each of the 4 intervals. Does that make sense? A little bit of sense? All right. Okay. Next up, let's do the example for graphing a basic trig function.